let's discuss about factoring a little bit more. After the trinomials, we are moving towards polynomials of higher degree. And this is an example of a polynomial which is of degree 4. And where am I looking for that? This is the x raised to power 4, which is telling me this is a degree 4 polynomial. How many terms do we have over here? We have 1, 2, 3, and 4 different terms. And my concern here is to figure out how can we find the roots or the zeros for this polynomial. Quite an easy thing. I will suggest you to look for those points where the curve intersects the x-axis and the x-intercepts. In other words, so what we will do, we will go to the Desmos. I have that same function plotted over here. So looking for the points where the curve is intersecting the x-axis, we have these points over here. How many points? 4 different points where the curve intersects the x-axis. So that's what I'm going to take into consideration. I will mention these same points. -1 is 0. So let's get back over here. And simply what I will do, I will try to list down here one by one. I will use the names factors and the roots or the zeros. We were supposed to find the roots or the zeros. Looking at the Desmos again, -1 is a point where I have the x-intercept of one of this. There is another one, 0 and a 0. So I'll get back over here and I will pinpoint x equals a -1 is one of the roots. X equals a 0 is the other roots. Now this helps me to figure out what are the factors. What I will do, I will change the sign from -1 to plus, and that will give me the factor. That means x plus 1 is a factor of this polynomial. If you remember, we have done the factoring. So I'm trying to claim over here that I can put x plus 1 as a factor and then multiply it with something else. That something else, we can find that using synthetic division or a long division also. And that gives me the concept of a factor. That multiple finally should end up equal to this polynomial, which we have over here. One more thing, the second factor over here, which is x, or the second root, helps me to claim that x is going to be a factor. And that tells me x times x plus 1 times another, I should say, trinomial or binomial should give me this specific polynomial. We have 2 other rational roots also in, when I'm saying rational, these are not the whole numbers, 0.18 and -1.847. I can bring those over here and claim that these are also the roots, 0.18. And there is another one where x is -1.847. Let's make sure that I have taken the values correctly. Okay, 847. So these 2 here are the rational roots. Rational means these definitely are in fractions. So I'm just ignoring those. I'm not going into that much detail that how will I find those. But you do know long division can help me to figure out these roots also. Continuing on the same pattern, here we have another question where we are discussing select which of the below are the factors using Desmos, obviously. So the factor, the polynomial that I have is this one, this whole polynomial, and I'm trying to figure out if all of these one by one, if this is a factor or not, this is a factor or not, this is a factor or not. We just figured out in Desmos that if I will try to bring in the other curve now, the one expression that I have just mentioned over there, I did a little bit of homework earlier, so I have that expression completely typed in over here for you to make it quick. So this is a factor. X-intercept is giving me clear hints about the factor. So 1 and the 3 are the two values which are the roots. We just discussed about that. So 1 and the 3 are the roots. That means x minus 1 is going to be the factor. Why do I have a minus 1 over here? Because root will always have an opposite sign from the factor. Why is that so? This tells me if x minus 1 equals a 0, that's how I will define the factor, and I will try to convert the factor to the root. So what should I do from here? I will add a 1 on both sides. When I'm adding a 1 on both sides, that means me to claim that x equals 1. Then is x minus 1 a root? Yes or no? Let me first mention over here that yes, these two, x is a root, 1 is a root, and x minus 1 is a factor. X minus 1, let's check if the function is intersecting the x-axis at x equals -1 or not. So we notice that the function is not intersecting the x-axis at -1, so it doesn't have an intercept over there. That means I will simply say here that no, this is not a root and this is not a vector. But here, x minus 3, let's get back over here and check if x equals 3. We have already checked it. 3 is intersecting here. The curve is intersecting the x-axis, or we have an x-intercept as at 3. That means x minus 3 is validly a factor. So I will mention here a yes. Like that. Now, one more easy thing that we can always utilize. If you're trying just to check if a factor, a root, is actually true, what I will do, I have already defined over here the function f of x. So I want to check if 1 is a root or not. So you see, f of 1 is a 0. That means whenever I have a 0 here, this means that I have this number 1 as a root, or this is the point x value where the function intersects the x-axis. So we can check the same thing for -1 also. And you see it's not a 0. That means we have -1 that's not an x-intercept. These are the hints that you can utilize to simply find out the roots of any polynomial using Desmos. Thank you.